Hello grade 6, and how are you doing? This is Miss Susan, and today's topic is about choose appropriate measures of center and variability. Lesson 13.5. So our lesson is connected to the two previous lessons, which are measures of center and variabilities. So our essential question will be,
how can you choose appropriate measures of center and variability to describe a data set?
So we gotta choose today which one is better one to describe any set of data or any group of data. Which one is the most appropriate measure? Is it the measures of center and variability? So if you remember from the previous lessons that we have three types of measures of center. We have mean, median, mode. These are the three measures of center. And we have the variabilities. We have range, quartile range, and mean absolute deviation. So let's start and implement our rules to find measures of center and variabilities and choose which one is better. So let's start. Hello, Doug. Hello, Mouse.
Hi! Horatio's neighbors had an acorn collecting contest at the park yesterday. I heard they had a good time. Each person had 5 minutes to collect as many acorns as they could. Once a whistle was blown, they had to stop collecting, and each person's acorns were counted. Check out the numbers of acorns that each neighbor found. Wow! Each person found a lot of acorns. Check it out! It looks like the mean of the data is 20. The median is 17 5/10. The mode is 14. And the range is 26. Which number would you use to describe the acorn data?
Which number is the
most perfect number to describe a data set?
Which number of these numbers is the most perfect number to describe any set of data? Is it the mean, median, mode, or range? And if you remember the range, it's the difference between the least and the greatest number. So look here with me. We have first to put numbers in order so we can find which number of these numbers is just in the middle of these group of numbers. So let's see, and I will explain to you more.
Let's find and compare the mean, median, and mode of a data set.
Let's read the question first.
Thomas is writing an article for the school newsletter about a paper airplane competition. In the distance category, Kara's airplanes flew 16 feet, 13 feet, 4 feet, 14 feet, and 17 feet. Should Thomas use the mean, median, or mode to best describe Kara's results? Explain your reasoning. Let's unlock the problem.
So, first, what are the givens? The givens here are the set of data. 16, 13, 4, 14, 17. What does he want me to find? He wants me to find mean, median, and mode of the data, then to compare these numbers and to find which one is the best one to describe any data. And we said the best number to describe any data, which is the best number which is just in the middle of any data. Okay, so let's see which of these numbers are just in the middle of any data.
To determine which measure of center to use to best describe the data, find the mean, median, and mode and compare them. Let's start by finding the mean of 16, 13, 4, 14, and 17. The mean is found by adding the data values and dividing by the number of data values. What is the sum of the data values?
So, as you remember, mean is the average of some numbers. And to find the average of some numbers, you have to add them together, then divide by the number of the data. If you add all the data together, it will give you
the sum
64.
is 64. Now divide by the number of data values, 5. What is 64 divided by 5?
I have 5 numbers, so that's why I divide by 5. And this is a long division. It will give you, if you made a long division, of course 64 cannot give you a whole number. So it will give you a decimal. It will give you 12.8.
64 divided by 5 is 12 and 8/10. So the mean distance is 12 and 8/10 feet. Now let's organize the data values to find the median. What is the order of the data from least to greatest?
To find the median, you have to find the number which is just in the middle of a group of numbers. And to find the median, there is one important condition, which is to order the numbers from least to greatest. So first, order the numbers before finding the middle number.
The order of the data from least to greatest is 4, 13, 14, 16, and 17. What is the median?
The median is the middle number here, which is 14.
Since the middle data value is 14, the median is 14. Now find the mode. Are there any repeated values?
No repeated values. This means no mode at all.
There are no repeated values, so there is no mode. Compare the measures of center to the data. Is the mean a good description of the data? The mean is less than 4 of the 5 values, so it is not a good description of the center of the data. Now, look at the median. The median is close to most of the values, so it is the best description of the center of the data. So Thomas should use the median to describe Kara's results.
So, which one is the best description for the data? It should be just in the middle of the data. So if you find the mean is 12.8. So 12.8 is located between 4 and 13. So it's not just in the middle of the data. So if you take the median to describe your data, 14 is just in the middle of the data. So it is the best number to describe the set of data because it is just in the middle of the set. Okay, so Thomas should choose median to describe the data. Let's see another example.
Let's compare the range and interquartile range of a set of data.
Let's first read the example.
Mr. Tobin is buying a book online. He compares prices of the book at several different sites. The table shows his results. Make a box plot of the data. Then use the plot to find the range and interquartile range. Which measure better describes the data? Explain your reasoning. To make a box plot, first order the data from least to greatest.
Okay, so we have here a set of data. These are the numbers here. And we need to make a box plot. So we need to make a graph, box plot graph to represent the data. Then after drawing the box plot, we have to find the range and the interquartile range. Interquartile range is the range inside the box, and the range is the minus the difference between the greatest value and the least value in the graph or in the table. So first, to determine the points that will help us to graph the box plot, we have first to order the numbers. So let's order the numbers from least to greatest.
The data is now listed in order from least to greatest. What is the median of the data?
Next, we need to find 3 medians. The median of the data, the lower quartile median, and the upper quartile median. First, what is the median of the data? The median is the number which is just in the middle of the data, which is here 16. 16 just in the middle of the data after organizing or ordering the numbers. So median is 16.
The median is $16. What is the lower quartile?
Lower quartile, this is the quartile here. Okay, so this is the lower part. What is the median of the lower part? Number which is just in the middle of this part, of this group, just in the middle is 14. So the lower quartile is 14.
The lower quartile is $14 because it is the median of the lower half of the data set.
The upper quartile.
What is the upper quartile?
Is the middle of this group. We have three numbers here. What is the middle of the three numbers? The middle of the three numbers is just a 20.
The upper quartile is $20 because it is the median of the upper half of the data set.
So let's graph the box plot. The least number is 6. The highest number is 37. And then put the median,
now,
lower
make
quartile,
the box plot.
upper quartile.
The box plot is shown above the number line. Use the box plot to find the range and interquartile range. The range is the difference between the
greatest number,
greatest value,
and the least value, or least
and
number.
the least value.
So 37 minus 6 will be
What is
31.
37 minus 6?
Would be 31.
The difference is 31, so the range is $31. The interquartile range is the difference between the upper quartile and the lower quartile. What is 20 minus 14?
Should be 6.
The difference is 6, so the interquartile range is $6. Now, compare the range and interquartile range. Which measure better describes the data? 5 of the 7 prices are within the interquartile range, between 14 and 20. The other 2 prices are either much higher or lower. So the interquartile range better describes the data because the range makes it appear that the data values vary more than they actually do.
So let me explain this part again. You know the range is the minus between the highest value and the lowest value. The interquartile range means the enter the box range. This means you will minus the upper quartile and the lower quartile, which is 20 minus 14. Now let's compare which value of these values can be describe the set of data perfectly than the other one. Okay, and I said the number that describes the data perfectly is the number that describes the center of the data. 20 and 14. It is in the center of the data, right? 20 and 14 is the number in the middle of the data. However, 37 and 6 is just on the edges of the data. It's so far from 20 and also so far from 14. But 15 is near 14, 16 near 14, 18 near 20. So 20 and 14 is the numbers that describing data better than 37 and 6. That's why 14 and 20 is much more in the center than the other numbers. And I said the numbers that more in the center of the numbers mean it is the best number to describe or the best value to describe any set of data. So that's why I choose the interquartile range. I always choose interquartile range because it is the best number to describe a set of data because it is in the middle of the data, and you know that the median's always in the middle of the set of data, right? So let's move to another example, and I hope that you understood this example.